How's it going, everyone? Welcome to another video on advanced Redux. And in today's video, we're gonna talk about is of this immutability things and what is the problems that immutable data wants to solve, or this particular concept is describing, and therefore it solves. So the idea of today's video is to not only be able to describe and mention a little bit of this advanced course or this advanced Redux course, which is using now RTKey, but also describe who the teacher of this course as a way to understand how do we get here. So Steve Keeney, he's the head front-end engineer at Temporal, which is a company focused on building is the durable execution platforms. You can think of this pretty much like some sort of Kubernetes with self-correcting and self-checking health status and other features that are needed in those environments when you need to deploy an application. And when if something went wrong, you need to actually know what went wrong and how you can recover from that. So again, this goes beyond the scope of this course, but it's important to at least know who is Steve Keeney, right? So the goal of this course is to know how this well-battle tested state management like Redux actually works, what is the problem that it solves, and in today's video we're going to take a look now is what this immutable data is all about, as a way to understand and to grasp this deeply problems, or these deeply nested problems that we have that right now. If you're going to learn Redux or you're gonna provide this service to companies, you inherit these particular problems, and you need to know how that things work and what is the problem that it solves. You need to know is the goal as well as the problem that it's trying to solve and their mechanism. So that's a very, very interesting. It also is a small a course, by the way. This is something that you can apply also to any other applications out there. So for any web applications that require you to manage the state of of your application, and by state I mean is the data models, and by data models I mean is, for example, if you have an e-commerce, users, order, products, category, that kind of thing, that kind of data. If you have now a financial application, it's like, well, transaction history, current balance, and that kind of thing, right? So because we want us to manage that state on the client side, there are certain patterns or architecture that allows to make that in a way that is easy to maintain and debug as well as read. So that is the Flux architecture. So this was developed at Facebook to solve that particular problem of how, by having you is now in a state on the client side, you can now is update that state in a way that all the UI elements, remember, after all we're creating is a user interface, all the UI elements on the applications are aware of this data. So this is like the single source of truth. So Redux actually provide now this Flux architecture, this particular way of doing that kind of thing. So anytime you want is to update or anytime you want to update, most likely. So anytime you want to update your state, this data, this model, you can do that by dispatching an action, and then that action goes through a reducer, which is this function that it takes now the state and this action that you want to do and generate a new bit of a state. So now it's going to replace that with this new state. So it's doing all of this a small chunk of updates to your model, which is a great thing. Then the problem here is that because anytime you want is to make an action, whatever it is, if you want to update that state or read that state, all right? So anytime you want to update that, or you want to make an action, it requires you to do all of these things over and over and over and over, right? So Redux say, or RTK say, well, instead of actually us to doing that, let me now provide you is a function that automates that particular process. So for example, the create slice, which is say, hey, in these functions, I need this kind of parameters, which is the initial state, the reducers, as well as the the name slice, or this name state, okay? And then I'm going to provide you is all of these actions, as well as with a proper type, the create actions, the types, the reducers, follow with the actions, right? Followed by the new states, or followed by the state, right? So this is something quite convenient because now RTK solves all of this ceremony. So it requires less ceremony when it comes to actually is update or mutate the state. So far so good, but here is when things started to become quite interesting, and especially as a way to solve this problem, like it's mutations, right? So because after all, this create slide give us is an actions, okay? We can actually now get all of the possible actions that we can dispatch or act upon that state, all right? As well as it is type, which is a great thing. We also need to know is how can we now mutate the state? And quite frankly, over the couple years, some programmers have found out that mutating a state, especially those that live in Java, they very well know that data mutation is one of the main source of bugs. So because your code is so gigantic and you don't know to which part of this state or this value actually go through, all right? So if you change the value of that or one of their properties, okay, so it can cause rippling effects through your entire applications, on the side rippling effects. So far we don't have any mechanism to know or to keep track at which state our states are. So what we do is just mutating the state, which is something that object-oriented programming, that's what it does, right? So you can is mutate the state, or therefore is reassign them with a new value, or doing that with new assignment, or in other words, it's like this particular value or property you want is to reassign them, or in other words, is create a new space in memory if you're using now objects. For primitive values, it's something trivial. It's like, you know that it's gonna do what it's supposed to. But for objects, things becomes quite a little bit fuzzy here. And by that is, when you now change the value of an object or any of its property, chances are that you're going to cause this rippling effect. And also, we don't have so far a mechanism of keep track those state change. That's one of the core problems that, for example, when you're using is context in React applications, is something that it can have all of these indirections. So one of the great things that Redux bring to the table is, hey, I'm going to provide you observability, or in other words, that the ability that you can now take a look at what is the current state of your data. Okay, so anytime you apply an actions, you know what is the next state. You apply another action, you know the next state, another action, the next state, another action, the next state, another action, the next state. You get it. You get the idea. So doing that is quite interesting. It's quite is also very helpful when it comes to maintain and debug these applications, but we don't have that natively in the language, in our objects. So this immutability, I'm going to present my case here of immutability, okay, because this is something relevant when it comes to create reducers. Okay, remember that after all, reducer is just this function that takes a state and an action to generate a new bit of action, a new bit of a state, my bad. So one of the problems that this create reducer solve is that you don't have to create that by yourself. It simplifies the creation from that, as well as provide more TypeScript better support, and also it's going to provide you to mutate the state in a JavaScript syntax. And I say mutate because behind the scenes, you're not mutating that. What you're doing is just to generate a new state using Immer. So Immer is this library that allows us is to, Immer here, Immer, yes, yeah, exactly. So Immer here is a German word from forever, always. Immer. Interesting that Immer is that that is a tiny little packet that allows you to work with immutable state in a more convenient way. What in the F is all of this jargon? Well, Immer stands for always. Okay, so it allows you to work with this immutable state, and this immutable thing or this immutable state is not what we mean on English or Spanish or any Latin language. I will argue that we think that things are static. It's like in this context, and that's one of the things that I really love about the anthropology as well, is that now for anthropologists as well as for software engineers, that context matters. Context is important, and especially here on the AI community, more than ever, we know that, right? Especially if you're gonna provide now not only set of instruction but also examples of this chat-based or these chatbots using the LLM, which is large language model, to generate texts, so Gen AI tools. The idea here is that you need to provide is a context, as well as all of the relevant data to actually give you the output that it needs to. So, yeah, and in this context, immutability means that data needed change to our data that needs to occur with intent. In other words, how do we control mutations? How do we keep track of all of our mutations? So there are two important mutation style, or two important immutability things that we need to pay attention here, or these two type of immutability here, right? Or this type of how we can control this mutation. One of them is by assignment, So by using the variable cons, and then you assign is you put some identifier, and then you assign is the value that you want to do. For primitive value, that's actually is useful. Is useful. So you don't have to. And the thing here is that this assignment here. So let me actually put an example here. Okay. So this assignment here, this immutable assignment. Okay. We're assigning immutability. For example, like this, you say, hey, user, right? Or let's say, hey, Tyrion, the Lannisters, right? The Lannisters. Or you say, no, let's go for something trivial. For example, price, right? Price. And so with this, we got now the price here. That's right, good, fine. And also, we can say, hey, this will be is a floating value, right? So with this as immutability assignment or assignment immutability, you can of course update the value of this. No, you can't, because you are assigning is a new one. So the idea of this is that this is fixed, right? So you can reassign something for that. And this is something that, for example, in primitive may work as expected. But when it comes to say, because actually you can reassign values to that. But when it comes to say now, to represent now objects, for example, like the Lannisters, and then you say, hey, this Lannister will have is now is the headquarters, right? Or the main house, or location. I don't know where they live. The Lannister location. Right, this House of Lannister is Casterly Rock. Okay, Casterly Rock. That's right. So you got now. This is the Casterly Rock. Right. Casterly Rock. Yep. Casterly Rock. You can say wealth. Right, let's say they have now 100 whatever coin they're using, right? What is the coin that they're using here? A Game of Thrones coin. Okay. Golden Dragon coin. Yeah, let's gonna make this. It's like, yeah. Oh my god, no. Right. Their wealth is valued in that. The currency they're using is the dragon gold. All right. So here, if you want to change the value of one of these property, which, for example, if you say, hey, the Lannister dot, let's say their wealth actually changed, and now it is something like it diminished, right? Now it's something like this. So they went through a war, and now that war cost them a huge portion of their wealth. Okay, so you got this 300, and you got this now is right, something like this, right? You might think, hey, I shouldn't be able to update that value or mutate that value because here is something that this cons is actually doing. It's like, no, the thing is that you can do. And that's exactly what is the confusion here, is that this cons is assignment immutability. Most of the time, especially if you are a functional programmer, where they are, one of the things that functional programmer does is to, instead of defining a lot of assignment, you create multiple functions that generate is a new state of that. That's one. And also, according to Kyle Simpson, is that another thing that it does is to try to predict where the errors will occur, and by using and avoid them by using some patterns to avoid it. Something that they mention here, and actually I take note of that, which is that it's like one of the things that functional programmers does is to try to predict where an error or when a bug, where the bugs are gonna be, and avoid them by applying some patterns to avoid that happen, where they can happen. That's the thing here. So you can now, again, allegedly for the functional programming, is that, hey, let me now try to predict where our errors will happen, and where the bugs will happen, and avoid that by using patterns that never happened. That using pattern where they can happen. So they are preventing that by using some of these patterns. A good example of this is if you want to keep your health at a top, at a peak, there are certain things that you need to do, certain practice, there are certain patterns that you must follow to try to avoid some disease, right? For example, a fleas infestation. Oh, you really want to avoid that, and there's some patterns and protocols that you must follow in your house that they can never happen, okay? Or where they can happen. Of course, when they happen, you know what you have to do, but to prevent that, you do these particular things. And this is a good analogy of how you can, how the functional programmers actually is doing. And one of the things that they do is to try to predict when the error where the bugs will gonna happen, and avoid that by using some patterns where they can never happen. So a real life example of this is if you know that fleas exist, I think you mentioned that, right? Fleas, right? Meaning or pronunciation, right?
Fleas.
Exactly. If you know that fleas exist, all right, you want, of course, to follow certain patterns and steps where they can never happen. That's pretty much what is doing this functional programming, according to Kyle Simpson. And those are recognize that most of the time, especially if you're a functional programmer, assignment is not an issue. The issue comes when you are changing the value, and that's when the discussion is all about here for that, because unlike assignments, they can only exist in that particular block scope, all right? If you keep that block scope small, or it's less visible in the viewport, that's not when the most of the problems actually happen. But because values are portable, so they can be in different places and move things, even to go through third-party libraries and go back here. Now, things here, and this is what causes most of this undesired side effects. So values are portable, and especially if you pass them by reference. So they can be in any part of the programs and even in third-party libraries. And I think that's where the problem of mutating data is focused and what we really care about. So anytime we pass down data as a reference, you need to ask yourself, how do I know that passing down that data isn't going to change in a way that produces a bug? This particular mindset, which to me is quite interesting, is something, it's now open up. It's pretty much when if you haven't heard about 420, and then you realize what that actually means, or similar with the financial, when you started to hear all of this, particularly concept like ROIs and MMR and NNR and all of this jargon specific, or in your particular field of expertise or interest, okay, whether it's in the artists or athletes or business, there are several of this jargon that happen. And once you understand that, you say, oh, this is pretty much what happened here with this particular mindset, with this particular way of when you're looking at your code, is to see, all right, how do I know that when I pass down this data, usually to a function, isn't going to produce a bug, right? So for that, there are several practices that we can do. One of them is for read-only patterns or for read-only data, okay, where you use now the object.freeze. And for those particular cases, when you want to build an application and the data that is read-only, okay, that is how you indicate when you pass down that data. It's like, hey, this data that I'm passing to this function, whoever is responsible for handling that is only read-only, okay, using the object.freeze. So this is a particular pattern of how you can now, as you write your application from this functional programming approach, to indicate to the user or the author or the maintainer of that code, hey, this data that I'm passing down here is read-only. And if you're writing a function, okay, always assume that the data that you're receiving is a read state only, and then you generate a new state of that. And then if you, for example, need to return, that you're going to return is a new state of that data. So when you return this new state of the data, okay, what you are telling to JavaScript, the concept of JavaScript, is to create now a new space in memory with this new update or with this new state, all right? And now you can share that to whoever needs that. So this is one way of how you can try to make things predictable with the functional approach. And all of this is because we're talking about this immutability thing, that is, how do we control mutations? How when you apply change, when needed change, when needed change needs to be applied to a data, when needed change needs to apply to a data, when needed change need to apply to a data, Yeah, when needed change, when needed change needs to apply to a data, uh, we need to know, or we need that change needs to occur with intention, with an intent. That's the idea of this. That's the idea of immutability here. Is that needed change that needs to apply to a data must happen, must occur, or needs to occur. Is a must. Is needs to occur with intent. So there cannot be is adding, or it shouldn't be accidentally or happening outside of our awareness, right? Happening at different times, creating race condition. No. This needs to happen with intent anytime we update the data, or anytime we change the data. So that's the whole point of this immutability according to Kyle Simpson. And how, as we mentioned, is that how we are talking about is this two type of immutability, which is the assignment, and quite frankly, if you are using now the function programming approach, that's not an issue, because most of the times functional programmers actually they don't care about to create is all of this assignments. In fact, what is in other words, and also this assignment is per scope, right? But data or value itself are actually portable. They are moving in through your entire programs and also in third-party libraries. So because of this immutability value, or this property of the value, so now with value immutability, we are now recognizing that, which is the vast majority of the problems here. And one of the things that this functional programming paradigm or this mindset is telling to us is to say, hey, let's going to try to predict when let's going to try to predict where the bugs are going to happen and avoid them by applying necessary practice, and and avoid them by using patterns where they can happen. Okay, so let's go to do that, especially when you are working with this kind of things, when you're working with values here. Is that because it is most likely that when you mutate the data, something wrong can happen. So let's go to try to identify the errors, or let's go to try to identify where the errors can happen. Let's try to identify where a bug can happen to avoid it by using some patterns where they can never happen. Right? And a good example is that the flea example that I mentioned before, which is great. And well, the practice here, these patterns are, if you're going to pass down data to a function, most likely, okay, passing down data to reference, when you need to do that, you pass down as a read state only, right? This is one of the pattern there. And the other is, if you're writing a functions, treat all of that state, treat all of those parameters as read only. So you generate is a new bit of a state. But if for programs is only in a read state, all right? So if you have a program that is only in a read state, is you just only download that, and this is practically static programs, and then you delete them. There's no value in there. So when it comes to now deal is with immutable or mutable data, we need to know is that how can we make this, and this is a very interesting problem, a very interesting topic that he mentioned, right? Which is you can what happened to data that needs to change. You can treat all of your data as immutable, okay, as read only, and some of them needs to change. The problem that immutable data structure want to solve is the ability to keep track of but again, I prefer to actually take a look now at the how do I put it? Yeah, at the what? There you got the this but let me actually refresh this. There you got it. Remember me. Good. Function purity, arguments adapter, point free. Closures, we also look at that closure, functional programming, memorization. So they are just techniques, right? Referential transparency, generalize to specialize. Partial application, but we were talking about is now the immutability here. Here, exactly.
So read-only data structures are data structures that never need to be mutated. Freeze it, you say it's done, it's final, it's complete. That's an object that isn't going to change. Or
exactly. For example, when you want to use this read-only, what is the applicability of this read-only data? Is like, for example, for configurations, right? Or when you get the data from a server, it's like that's the final state, all right? And this is something interesting because in Java community is like, so they made this keyword called final as a way to guarantee that there is no tripping ideas about if this is now the last value. Can you assign this last value? Can you is to avoid the stripping idea between assignment immutability and value as immutability. When they say, hey, you know what? Well, it'll be much more better for us to have a keyword that say this value final, this value that I'm assigning as using the final keyword, this will be is the last value. You won't change that, period. Deal with that. So yeah.
Or at least it shouldn't, otherwise we're probably going to have bugs that we don't expect. So that's an example. When we pass in an object, when you pass in a configuration array or something like that, you even take a JSON response from an API. That's a value that's done. It's come back from the database. It's come back from the API. It's done. It ought to be marked as read-only because there's no reason for us to be mucking with that in some way that's going to end up creating a misexpectation and therefore a bug somewhere else in the code. Those are all data structures that don't need to be mutated. But that certainly can't be all of our data structures. We certainly can't imagine a program that would do anything useful if all of our data structures were in this read-only state. Some of them, sure, but all of them in a read-only state would mean a program that was fixed and did nothing, and we could just delete it and move on. So when I take that process order function, and I'm not even thinking about what somebody might have done with that order object after having called me, I'm just trying to make sure there's a particular flag, a side effect. So about this entity, mutable, something like an array or an object, then it is incumbent upon you, the author of the function, you don't know all of the call sites for this function. You don't know whether they're going to pass object.freeze or not. The best thing for you to do is to always assume that it's a read-only data structure. Always assume that you're not allowed to mutate it. Don't assume that because you mutate it and you don't see an error at that point, that nobody else is going to try to pass in an object.freeze data structure, in which case you would have a fatal failure. Always assume that you're not allowed to do line 3, you're not allowed to mutate it. So what do? We need to add a status field to it before we save it to the database. The answer is you make a copy of the object.
Mm-hmm.
You make a copy of the object, which is what I'm doing on line 2, and that copy, I'm simply using the ... operator, that's object spread. You make a copy of that object, and then you can mutate it internally all that you want, because you're not having a side effect on the outside program. You should always assume that it's a read-only data structure, no matter what. So there's two sides of this issue, and don't lose track of them. One side of the issue is that when you call a function and you're going to pass in a data structure, do your reader the benefit of annotating it that you want it to not be changed. Use something like object.freeze. And secondly, and maybe even more importantly, when you write a function that receives data structures, treat it as if it's read-only no matter what. Make a copy of it, make your changes to your local copy. That's how we deal effectively with value mutability. But again,
exactly. That's how we deal effectively with value immutability.
So read-only data structure deal effectively
with value exactly value mutability. Exactly. That's how we deal effectively with value mutability. Okay. Cool.
With value mutability. But again, that still only tells us something about data structures that never need to change. What do we do with data structures that do need to change? Well, you can't treat all data structures as immutable data structures, as read-only data structures. Some of them are going to have to be mutable. And here's the real counterintuitive thing. When you have the need for a mutable data structure, that is one that is not read-only, what you actually need is an immutable data structure.
When you need, okay, we're talking about is need here, opportunities. Pretty much like sales pitch, that kind of thing. So when you need
as read-only data structures, some of them are going to have to be mutable. And here's the real counterintuitive thing. When you have the need for a mutable data structure,
okay, so when you have the need for mutable data structure,
that is one that is not read-only,
that is one that is not read-only, correct? So when you need to have,
and here's the real counterintuitive thing. When you have the need for a mutable data structure, that is one that is not read-only, what you actually need is an immutable data structure.
So when you need to have,
let me say that again because it's really strange. When you need a mutable data structure, what you actually need is an immutable data structure.
Now is to identify, right? When you need a mutable data structure, when you actually need an immutable data structure. So the naive approach here will be is to, well, have an immutable data structure, right? You know, right?
So what am I talking about here? What do I mean by that? An immutable data structure is one that allows not no mutation, but rather
exactly. An immutable data is a data structure that is that allows is not mutating, but that allows is to know when the data change or when needed change to the data, it has to be, or it needs to be with intent.
Structured mutation. Structured, controlled, intentional mutation, as opposed to just willy-nilly make an assignment statement and create a side effect somewhere. It's the next level from a read-only. You should start by asking, is this ever going to need to mutate in any way, shape, or form? If so, then I don't use a read-only. I need to do something immutable. But if it never needs to change, then just stick with the plain, simple read-only data structure. We only step up to this immutable data structure if it needs to mutate. So what exactly is an immutable data structure? It is a representation of the data structures that we are used to dealing with. We're used to dealing with data structures like arrays, where we can access things.
I think this particular question is quite interesting here because, again, this is what is now all of this Redux or state management problem they're trying to solve. Is that when you need the when you need a mutable data structure, when you actually need is an immutable data structure. An immutable data structure is immutability. It means that not need to change, but that change that happens, that needed change that happened to this data needs to be with intent, needs to occur with intent. So that's what we need, is to have some sort of mechanism here that makes a lot of sense to actually know when this data change. Okay.
At index positions. We're used to dealing with things like objects, where we can access things at named property positions. It's things like that. It's data structures like that. But where you don't have access to the actual underlying data structure, what you have only is an API.
There is a reason. Oh my French toes, guys! There is a reason why then is this kind of applications actually using is Redux instead of React and blah 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 blah. Because at the end of the day, this Redux, this way of how you can now have control of the state change of your data is something that is what we want. It's what is desired on these client applications. Interesting. And why now Imer, instead of actually creating this new wrapper or new API for that, it's I'm just going to create now is a proxy and detect those change. So when a particular value is changed, I'm going to detect that. All right, I'm going to now apply those changes to this draft objects, and when that is done, deploy that, right? Or provide you the next state. That's something interesting, and they're using is now the proxy object for that. So for example, frameworks like Vue actually, when they want to handle is this reactive reference, what it's doing behind the scenes is using is the proxy, is that, hey, the data changed here, therefore I detect that. Or in other words, so when you assign a new value to a property in an object, it has a proxy object, which is also is a structural design pattern. I think it is design patterns. It's a structural it's a structural. Yeah, it's a structure because what it's doing is to detect that structure, is to intersect that. Exactly. If you provide a substitute or placeholder for another object, it's like, hey, this is the placeholder, this is the substitute of another object. A proxy control access to the original objects, allowing you to perform something either before or after the request gets through the original object. So the structural design pattern. So proxy is a structural design pattern. That's something quite interesting here. The intent. Proxy is a structural design pattern that lets you provide a substitute or placeholder for another object. It's a substitute. Oh shit, are they gonna plan to kill him? Oh. Exactly. The problem, why would you want to control access to an object? Oh my god. Especially when there is a lot of people actually interacting to that, and you need to have control about. That's one of the reasons, for example, database are well aware of that. They need to have that. Database query can be really slow. Here's an example of you have a massive object that consumes a vast amounts of system resource. You need it from time to time, but not always. You could implement a lazy initialization, creating this object when it's actually needed. All the objects client will need to execute some deferred initialization code. Unfortunately, this will probably cause a lot of code duplication. In an ideal world, we wanted to put this code directly into our own objects class, but that isn't always possible. For instance, the class may be part of a closed third-party library, which is the class here. If this class is part of a third-party library, you don't have control of what it's doing behind the scenes. So the proxy pattern suggests that you create a new proxy class with the same interface as the original service objects, and then update your app so that it passes the proxy object to all the original objects client. Upon receive a client from a client, the proxy creates a real service object and delegate all the work to it. The proxy disguises itself as a database object. It can handle lazy initialization and result caching without the client or the real database object even knowing. So the real life analogy here. A credit card is a proxy for a bank account. Okay. A credit card is a proxy for a bank account, which is a proxy for a bundle of cash. Yeah, allegedly. So this is a proxy of my bank account, which is a proxy of a bundle of numbers of cash that you have. Both implement the same interface. They can be used for making a payment. Exactly. Both implement the same payment, the same interface, or the same goal. All right. Whether it is the credit card and the cash, a consumer feels great because there is no need to carry a lot of cash around. A shopper owner is always happy since the income from transaction get added electronically to the shop bank account without the risk of losing the deposit or getting robbed on the way to the bank. So this is some real life analogy of the proxy objects, right? So these proxy objects allow you is to handle now in the context that's interesting here. It's a proxy. So the credit card is a proxy of the amount of your bank account, similar to the cash. So the idea of this, right, is that because now Immer is using this proxy design pattern, is this wrapper, okay, that let you provide a substitute or a placeholder for another object, okay. So for example, in this context is to actually intersect is when a value is changed, okay, and then in the context of Immer is say when this value change and when this property of this, when the property of a particular object change, I'm gonna now create is a new, I'm gonna have this draft where this will hold is the previous state with the new updated data, and then create is a new state out of that. There's some couple question here is that Immer behind the scenes is creating is Twitter. Nope. Then you have, why these freaking people don't have Twitter accounts or that kind of thing? Perplexity, bro. Does Imer preserve the draft history in memory? Does Imer preserve the draft history in memory? Imer does not inherently preserve a draft history in memory. Instead, it operates on the principle of creating a temporary draft state that allows for mutable-like syntax while ensuring immutability. Data creation, state production, no built-in history. While Imer tracks change to create a new state from the draft, it does not maintain a history. Okay. Each call to produce results in a new state without retaining reference to the previous draft. Okay. Efficiency. Okay, that's quite interesting. That's quite interesting. Does Imer preserve draft history in memory? No. It just use the draft. No, it just use the draft to mutate, to add the update, to add the mutations to the data, and then generate the next state. That's interesting. Using proxy built-in object in JavaScript. That's interesting. That's very interesting. Efficiency with structural sharing. Oh, that's interesting. Highly performing, especially when it comes to large objects under the hood. I may use object.freeze during runtime to make the object read-only, which leads to perform issue when working with large objects. Nested object take a special large performance hit because object.free needs to be run at each level of the object. Exactly. To address this, Imer has an entire resource page dedicated to improve performance while using the library. Holy hell. What's a structure? Yes. Structure is relatively new library designed to be nearly identical to Imer in terms of usability, but is much more performant. Through Structure and Imer share the draft API concept and produce a new state by updating a draft object. The way they operate under the hood is fundamentally different. Imer use object.freeze during runtime to make object real. To make the read-only object. Structure a freeze object at compile time with TypeScript using custom type. The performance cost of making an object immutable is reduced to 0 because no work is done during runtime. It is fairly innovative concept. Here's an example using structure to update immutable state. Interesting. It does that at compile time. Okay. Oh, I get it. Imer performs. That's very interesting. Structural JS. Structure, not strict copy. Operations per second. Immutable, not to JS. Interesting. Interesting. And then you got immutable. Immutable. Okay. Immutable. Nested object, many modification. Nested object, few modification. Simple object, many modification. Simple object, few modification. Simple object, many modification. Nested object, few modification. Nested object, many modifications. Complex object, few modifications. Interesting. Interesting. So I'm use object.freeze to achieve immutability. Structure, but I think the structure is, again, is you are going beyond. It's like, okay, there are something. Okay, structure JS can find complete docs. There you got it. That's interesting. Interesting. They're using is now TypeScript to do that. Okay, pull products as far as that. Performance tips. Here are some performance optimization. Okay, but then you got is now the immutable to JS. Okay. But it's because now this was made by, I get it. It's because this was made by that. Okay. Okay. All right. Okay. Okay. Flow and TypeScript. The idea of flux. That's interesting. That's very, very interesting. Immutable GS provide an API to create immutability. These are the kind of problems that, these are the kind of problems that front-end applications are facing. The web apps that front-end engineers are facing. This is the kind of problem that front-end engineers are facing. That's quite interesting. That's very, very, very interesting. That's very, very, very interesting. That's very, very, very interesting. That's very, very interesting. Because this is the kind of problem that this is the problem that they are actually facing. And we have to face those problems. And we have to come up with some solutions. Okay. So front-end challenge. This is the kind of problem that we are going to face, especially if you're building our applications, modern web applications like that. Okay. So Immer just use a draft to add a mutations to generate, then generates the net state using proxy building object in Java, using the proxy building object there. So Immer use object-free to achieve immutability. And here are some of the performance optimizations for that. Okay, Immutability GS. Okay, this is the core of all of this shit. Okay. Interesting, very, very interesting. Immer just uses the draft. So the front-end challenge is exactly. So front-end challenge. Data. Exactly, the front-end challenge. Assignment immutability versus value immutability. Yeah, assignment immutability versus value immutability. Exactly. The challenge ahead for front-end engineers. The challenge ahead for UI's engineers. The challenge ahead for UI engineering. Yep. The challenge ahead for UI engineers. The challenge ahead for UI engineering. What problems do we solve? Exactly. What problems do we solve and how to do it? (2024). Okay. The challenge ahead for UI engineers. What problems do we solve and how to do that? 2024. Assignment immutability versus value immutability. I may use an object of free to achieve immutability, and here are some of the performance optimization. Immutable JS provides an API to create immutability. Some sources are more performant. Yeah. Most performant. The fastest. Yeah. The fastest. 2024. For the vast majority of issues of data immutability of use cases. That's quite interesting. That's bloody hell interesting. Okay. Are facing, and if you are a UI specialist, it is better for you to be ready. It is better for you So this is the kind of problem that front-end engineers are facing, and if you are a UI especially, it is better for you and your business and the service you provide. Okay. It's better for you and the service you provide. Yeah, these are the kind of problems the front-end engineers are facing. And if you're an UI especially, it is better for you and the service you provide to know about it, and how to solve it. At least given the tools, given the mature tools, and at least given the mature and industry tools and industry leader tools out there. This is a problem that actually we as front-end engineers were trying to solve, right? So describing UI, it was just a side effect of all of this, because at the end of the day, it's all about state. It's all about how can we now keep track of state change for those times when we need to mutate the state. And for those times when you don't need to mutate the state, we already have some particular practice. So we know how to come up with that kind of thing. Oh, my French toast guy, bro. My French toast guy. That's very, very interesting. It's like, I need to write an article about this. Yeah, completely. But it's like, oh, that's powerful, bro. That's powerful. That's very, very powerful, bro. No, I think this is what we really care about. And then you get a structure and immutable. And I think I'm going to dedicate time. Okay, I'm going to dedicate time to actually read about that. Why is that? Because this is what we really care about. This is the problem that actually. This is the problem, and what is the possible solutions that we have come out so far, right? Oh my God. Oh, Nick. Oh, okay. Oh, my French toast guy, bro. Jesus. Okay. Yeah. Themes. Exactly. Fronting challenge. Assigning mutability versus value mutability. Okay. State management. Is where the value state management value the value of front end, exactly, state management. The value of front end engineers. State management. The value offering of UI engineers to companies. Yep. State management, the value offering of UI company. Describe the problems exactly. Describe the problem the company have by using top-tech tools to build web apps, to build their web apps. To do describe the role of UI engineers and the problems they face, particularly with state management. One of the values, one of the value offering of UI engineers to companies. Describe their role with state. Assignment immutability. Immutable and immutable data. Make a subtitle. And description. Yeah, make a subtitle. Make a subtitle and description of make a subtitle and description of immutable data. Assignment immutability. Of the solutions. Okay. I may just use a draft to add mutations. Okay. 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 Right front end challenge 2024 in my blog. Okay. Holy moly. Mhm. Exactly. These functions create that new state by actually mutating as a draft object in another JavaScript syntax, okay, and then generate that. So this new state, it must be different exactly in memory, but their values must be true. Exactly. You're creating is now this copy of that. Redux toolkit and nightmare. Mm-hmm. Oh, you're gonna throw an error because you are mutating, is that? Mm-hmm. Mm-hmm. Okay. Updating nested objects. Ah, well, with updating nested objects to say, hey, um, you either is Imer can track updates to a primitive values. Okay. This object will still wrap in a proxy, so we can mutate it. Mm-hmm. Okay, newly update. Okay. Drastically simplify immutable update logic. The accidental mutation and the number one cause of Redux bugs is a huge improvement. Yeah, I get it. Mm-hmm. Architecture and intent. Okay. Wow, holy F. We're not changing the design. Okay, so they're gonna stick with that. Okay, cool, cool, cool. Alright, 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 makes sense, makes sense, make ton of sense. 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 Oh my god. Thank you, bro. So yeah, that'll be all for this video. Take care.